tutorial is for 4th grade, Module 4, Lesson 9. In this lesson, we're going to use the angles on pattern blocks. We're going to put those angles together to show how they can create larger angles. For example, I have an angle here, and in the center of the angle is a triangle and a square. And we're going to determine the measurement of the entire angle and look at the smaller angles that create that angle measurement. So I have a drawing of the same configuration here, and the first thing I'm going to do is pull up my protractor to see what the measurement of the entire angle is. So again, when we measure our angles, we want to make sure this dot is right at the vertex of the angle, and the bottom side of the angle is running through this line here that represents the 0 line. So I'll get that lined up a little bit better. And then I just need to look and see where the other leg of the angle enters the protractor, and that's at 150 degrees. So the entire angle is 150 degrees. Now I just need to figure out the angle measurements of the square and the triangle. I'm going to use my protractor for that as well. I'll start with the square, so I'm going to keep my protractor lined up here because the bottom of the square is running along that bottom angle. The side of the square runs through the 90-degree point. So I know that this part of the angle is 90 degrees. So 90 degrees would be this part of the angle. And again, that makes sense because that's a right angle and squares have right angles. Now I need to find the measurement of the angle of the triangle. That would be this angle. So I'm going to need to turn my protractor, and I'm going to run this along the side of my triangle. Get that all lined up. So the dot is on the vertex. The side of my triangle runs along the 0 point on my protractor. Now I just look at the other side of the triangle, and that matches up to the 60-degree mark. That tells me that this angle is 60 degrees. So now let's transfer this information back onto our worksheet. So the entire angle measurement was 150 degrees. The angle measurement on the square was 90 degrees, and we combined that with the angle measurement of the triangle, which was 60 degrees, and that got us to that total of 150 degrees. Looking at the next question, I have a hexagon and a triangle, and we've put together two of those angles here, and we're going to measure the angle that they make when we put this angle of the hexagon next to this angle of the triangle. This would be considered my vertex, and I'm going to change my screen again to show how we can measure those angles. So this picture shows the same configuration of the hexagon and the triangle, and again we're going to measure this angle that's created when we put the triangle next to the hexagon. I'll pull up the protractor, and I'm going to line up this dot on the vertex of the angle. I'll need to rotate my protractor a little bit to do that. So I line that up. One side of the angle is running through the 0 point, and then if I look along the other side, it's running through the end of the protractor as well. Well, this is the 170-degree mark, so this last line would be 180 degrees, which means this angle is a 180-degree angle, and that makes sense because it is forming a straight angle. Now I just need to find the measurement of the two angles that made that 180-degree angle. So first I'll measure the angle on the hexagon, and I'll use the protractor for that. So this is already nice and lined up. So this leg runs along the bottom of the hexagon. This side goes through the hexagon, and that would be 120 degrees. So this angle is a 120-degree angle. And now I'm going to measure the triangle's angle. So I'm going to turn my protractor for that. run that through the vertex. So I've got my dot lined up on the vertex, the side running through the 0 point. The other side of the triangle comes out at 60 degrees. So we have a 120-degree angle and a 60-degree angle to make the 180-degree angle. And we'll put that information back on our worksheet as well. So the entire angle was 180 degrees, and that was made from this 120-degree angle plus the 60-degree angle from the triangle. And that gave us the straight angle of 180 degrees. If you look at the next diagram, we have an angle that's actually opened up wider than a straight angle. So I know that this angle is going to be greater than 180 degrees. I'm not going to use a protractor to measure these angles because I'm going to use the knowledge that we already have about the angles on the square and the hexagon to determine the total angle measurement. So the square has that square corner, so I know that the first part of the angle is 90 degrees. And we looked at the hexagon in the previous problem, and the angle on a hexagon is 120 degrees. That means all I have to do is add 90 degrees to 120 degrees, and that is 210 degrees. And that tells me that the total angle measurement is 210 degrees. And again, it's opened up wider than a straight angle, and that makes sense that it would be larger than 180 degrees.